Okay. Okay, dear student, we are conducting the snap of our student bank test and this snap for a communication and for a DRDO. Okay, bank test, very basic question from the communication. First of all, what is the difference between analog modulation and digital modulation?
In analog modulation, message signal is in continuous analog form. In digital modulation, message signal is in bits form, binary bits.
Okay, can you explain digital modulation? Why any of the example using graph, etc.?
Digital modulation PCM, like example for digital modulation PCM. PSC, ASK, PSC.
Hello.
Yeah.
PCM is the example.
Yeah.
Okay, so please explain PCM.
Okay. In PCM, we
first of all draw the block diagram and explain one by one by using of input and output graph. What will be the input of the first block? What will be the output of the first block? Take any of the input and give the output. Understand?
Okay.
Okay. You are done?
Yeah. Yes.
This is the input and output of the sampling. Then quantizer. After the quantizer, what is the next block? Quantizer is the last block.
Yes, sir.
After quantizer, how it gives the digital output? Give me the please understand how after the quantizer is it the digital output? आपने जो बनाया हुआ है क्वांटाइजर उसको देखा वो क्या डिजिटल आउटपुट है क्या आपका?
Yes, sir. Encoder will be there.
Where is the encoder? See in the your block diagram there is an encoder or not?
Yeah, actually I forgot that. Encoder will be there, sir. After encoding, digital output can be transmitted to channel.
Okay, please see show me one more time your graph, your block diagram. Okay, so let me first of all please explain what is the sampling and what is the quantization, how they work.
Sampling is the process of discretizing the signal in time axis.
Okay.
Quantization is process of discretizing the signal in a y-axis, in amplitude axis, to round up nearest integer to the sample value.
Okay. How to do sampling? What are the method we have for doing the sampling?
Theoretically, ideal impulse train sampling is there, but practically we can use flat.
What is the ideal
finite duration?
What is the ideal sampling?
Here we are using impulse train, ideal impulse train.
I didn't understand.
In
Okay.
practical situation, we are using finite duration pulses.
Finite duration impulses.
Yes.
Okay. Can you explain the Flintoff sampling?
Flat top sampling.
Yeah.
In flat top sampling, the sampling it is not impulse. It is of rectangular pulses of finite duration. There we sample using continuous rectangular pulses. The amplitude will be flat during that pulse width.
Okay. Please explain sampling theorem and what is the disadvantage of the sampling theorem?
Sampling theorem it tells us that if we sample the message signal minimum twice the maximum frequency component of the message signal, then we can reconstruct the message signal from its samples.
Okay. What is the advantage? कुछ advantage है इसमें? Disadvantage, advantage.
Advantage. Yes, sir. Advantage is that we can convert the signal into discrete form. That is advantage.
Okay.
And disadvantage is that quantization error. After quantization, we cannot recover that exact signal.
After quantization, we cannot cover exact signal.
Yeah. It's an analog
I
signal.
am asking the disadvantage of sampling, not asking the disadvantage of PCM. Understand? What is the question? First of all, we have to understand the question. Understand?
Okay.
Okay. Now,
Disadvantage of sampling.
disadvantage of
Sampling.
theorem.
I don't have any idea.
Okay. What is the white noise?
White noise is the noise. It's noise for spectral density and occupies the all frequencies band.
I think you are not 100% confident in the noise.
Yes. Noise in white noise means it occupies in all frequencies over all the frequencies.
Okay. And explain the different type of noise.
Thermal noise, flicker noise.
How noise affect the signal?
Noise affects the signal by superimposing noise onto the signal. It can be additive, like additive white Gaussian noise.
Okay. Now I come to the analog modulation. What is the frequency modulation?
Frequency modulation, carrier frequency we are changing with respect to the message signal amplitude.
So in this, in the frequency modulation, we change the carrier frequency.
Yes.
Okay. According to the
amplitude of the message signal.
According to the amplitude of the message signal.
Yes. Yes. Sir.
One minute.
Yeah.
Okay. Currently, I am on the station and going outside. So
Yeah, I understand.
Okay. What was the question? What is the frequency modulation? Okay. You told that the frequency of carrier signal change according to the amplitude of the message.
Yes.
Now, what is the amplitude modulation?
Carrier amplitude we are changing according to the amplitude of the message.
Means in all the modulation, we change the carrier according to the amplitude of the message.
Yes.
Okay. What are the different modulation scheme? Frequency modulation scheme.
Frequency modulation, amplitude modulation, phase modulation.
Now, frequency modulation. What are the modulator? Different type of frequency modulator.
Okay.
Explain anyone.
Uh,
First, make the graph
direct
or diagram, block diagram, anything. Then explain.
one type of frequency modulation we can direct frequency modulator we can use by using voltage controlled oscillator.
VCO.
Yeah.
What is the VCO? How it works?
Uh, VCO is a basically it is a oscillator in the, like tank circuit in that LNC. Capacitor can be capacitance can be varied by biasing voltage. It's biasing voltage like varactor diode.
Okay, draw the diagram of VCO.
Sir, I'm drawing a simple LC circuit.
Okay, show me. So this is the tank circuit. LC
Yes.
tank circuit.
Yes, sir.
So this work as a VCO.
Yes, sir. In that, the capacitor is variable based on the voltage.
So this is like a old varactor diode. In the varactor
Yes,
diode
sir.
also capacitance is changed.
Yes, yes. Varactor
So why
diode, yes,
we do not use the varactor diode instead of this circuit, because this is the bulky circuit. We know that whenever the inductor comes, it becomes the bulky.
yes.
So why we are not using the varactor diode?
This capacitor actually I represented by using capacitor. It is actually varactor diode. At the same time, you need inductor also for oscillation.
I'm not getting your answer. My question is, why we are using this LC tank circuit if we want that voltage change occur and capacitor change, then we can use varactor diode. My question is, what is your answer? I'm not satisfying your answer.
Why? Because sir, varactor diode it contains only capacitance effect. We need inductor also for us for generating oscillation.
What is the oscillator?
Oscillator by oscillator generates the AC signal.
Oscillator generate AC signal.
It oscillates by converting DC.
I think you are not getting the basic concept of oscillator. Oscillator generate the AC to convert the DC into AC. So it is the DC to AC converter. How it oscillates? You told that oscillator is convert AC to DC or DC to AC or AC to DC.
For biasing purpose, we needed DC for oscillator, sir. Actually, it is generating oscillations. It is triggering oscillator by from noise itself and starting oscillation.
Okay. Now come to the next question. What is the alpha in the case of amplitude modulation?
Alpha.
Mu.
Mu. It is a modulation index.
It is modulation index. So suppose we have the mu less than 1. Oh no, mu we have the mu greater than 1. So what type of problem we can get from the circuit, or we can get from the process when we have the mu greater than 1?
In modulation index greater than 1, amplitude distortion will occur with modulated waveform, like zero cross.
Okay, then what happened? Is there any fraction on our receiving point? Is there any problem on our receiver, or we can get perfect signal at the receiver?
We cannot get perfect signal. For suppose if we are using envelope detector, we are not able to recover that.
If suppose I am not using the envelope detector, then what happened?
For mu greater than 1, we can use synchronous detectors. I mean coherent detector.
Okay, okay, Venkatesh, your time has been completed. Now let's conclude your interview. Your technical knowledge is good, but sometimes because in the DRDO, they will ask the question from your answer, and they will go more deeper and deeper. It may be then your answer will be the next question for them. Understand? Okay. So first of all, you have to told very carefully. You have to give answer very carefully. Suppose you are not able to understand oscillator. Understand? So first of all, we have to give the answer in proper manner. Proper manner means we have to frame the answer in proper way. First thing. Understand? Now the second thing, we have to revise the basic concept. Okay, like VCO, it is a very important concept. Okay. Now your technical is good. Out of 10, I will give the 7.5 to the technical, and I give the 7 to 8 for your confidence. Your confidence level is also good. Okay. Hello.
Okay, sir.
Okay. Okay, Venkatesh, best of luck.
Oh, thanks.